Hi, I'm Maxine, and this is my lab 4 on oscillations. So we want to be able to analyze the motion of a mass on a spring as it spins in the x direction and in the y direction, and we want to be able to use GlowScript to create a computational model for this, to which we can then apply the energy principle and make predictions and test them using GlowScript and the video that was provided that I tracked with Tracker. And so my graphs and my results, had a fair bit of error, so they're not perfect, but largely they demonstrate the principles, I feel like, of the lab. So the energy principle and Newton's second law are the two main principles here. These are the positions, the mass, the length of my object. And here's my tracker analysis. All right. Oop, sorry, there we go. And then this is my GlowScript code. I don't know how visible that's going to be, but I promise it's there. And that I did what I was supposed to do with it. So, yep. And so here were my results. This was my spring motion. So probably a little heavier than it should be, which I think is kind of shown in the X and Y position graphs, where this is like really wonky. And this is also like mildly wonky, but like overall it's the idea of the oscillation, it's all there. And then for this graph, it's the idea of the change of the individual components is present, but in terms of the change in energy overall, it's about 0 due to the law of conservation of energy. So one possible source of error, and probably the main one, is just human error, whether that may have been bad calculations, bad rounding, or just me not doing the best possible job at doing the click pointing in Tracker. And then the computational model also just does not take the entire system into account, right? It really only takes into account the spring force and the force of gravity. So if there's any other work done within the environment, then that's not taken into account. And so there's thus a fairly limited scope and room for error with this. So is the energy principle satisfied? Yes. Even with my graphs having some things that are sort of wonky, as we saw earlier, the change in overall energy is 0. So based on the law of conservation of energy, where energy doesn't get added and doesn't get taken away, that is satisfied because it stays the same, it just changes form. Then my Y position estimate was 6.9 newtons per meter. Then my X position estimate was 5.7 newtons per meter. And so I think that using X would have probably made X, like the X position graph, match better than the Y graph for what would have been expected for it. Instead of the opposite of Y looking better with it. Obviously, this is assuming that, my things are correct, where they may still both look a little strange, but overall, it would probably just make X look slightly better because the period would match better for what X had. Anyway, that is my lab. Thank you for watching. Cool.